So let me discuss first in, first out algorithm. So I'm going to explain this algorithm by considering the following reference string. So what is this reference string all about? As we know that a process P will be divided into a set of pages or a sequence of pages. And CPU, in order to execute a process called P, it is going to request the corresponding page numbers, right? So here the reference string says that CPU, in order to execute a process called P, first it is going to request page number 7, followed by page number 0, followed by page number 1, next page number 2, page number 0. Like this it goes on, and finally it's going to request page number 1 in order to execute the process called P, right? Now, CPU, in order to execute the process called P in the following sequence, the 3 frames has been allocated inside the RAM. I repeat, CPU, in order to execute the process called P in the following sequence, totally 3 frames has been allocated inside the RAM. So these 3 frames are represented in red color, right? So now CPU, in order to execute the process called P, is going to request the first page number. Now since the page number 7 is not present inside the RAM, we are going to call it as a page fault. And now we need to move this page number 7 from CPU to RAM. So once we move page number 7 from CPU to RAM, our RAM looks like this, right? So here only I have written 3 frames. Why? Because for process P, in order to complete its execution, only 3 frames has been allocated, right? So now CPU is requesting for page number 0. Now page number 0 is present inside the RAM. Page number 0 is not present inside the RAM. So since page number 0 is not present inside the RAM, we are going to call it as a page fault. And this page number 0, we need to move from hard disk to RAM. So once we move page number 0 from hard disk to RAM, our RAM looks like this, right? So next CPU is requesting for page number 1, and page number 1 is present inside the RAM. Page number 1 is not present inside the RAM. So since page number 1 is not present inside the RAM, we need to move page number 1 from CPU to RAM. So once we move page number 1 from CPU to RAM, our RAM looks like this, right? Now CPU is requesting for page number 2. Page number 2 is present inside the RAM. Page number 2 is not present inside the RAM. Since page number 2 is not present inside the RAM, we need to move page number 2 from CPU to RAM. Now the question comes, now which page number needs to be replaced with page number 2? I repeat, which page number needs to be replaced with page number 2, right? So in order to determine this, we are going to use first in, first out algorithm. First in, first out algorithm says that the page number which has entered the RAM first, that needs to be replaced. Among 701, the page number 7 has entered the RAM first, therefore page number 7 is replaced by page number 2. So once page number 7 is replaced by page number 2, our RAM looks like this, right? So next CPU is requesting for page number 0. So page number 0 is present inside the RAM. Yes, page number 0 is present inside the RAM. So we are going to call this as a page hit, not a page fault. Why? Because the page number 0 is already present inside the RAM, right? Since the contents of the RAM has not been changed, I have not written here, right? Next CPU is requesting for page number 3. Page number 3 is present inside the RAM. Page number 3 is not present inside the RAM. So since page number 3 is not present inside the RAM, we are going to call it as a page fault, right? So now we are moving page number 3 from hard disk to RAM. So once we move page number 3 from hard disk to RAM, so one of the page number should be replaced by page number 3. So which page number needs to be replaced by page number 3? So among 201, page number 0 as a write first. So therefore page number 0 needs to be replaced by page number 3. So once we replace page number 0 by page number 3, our contents of RAM will look like this, that is 2, 3 and then 1. So next CPU is requesting for page number 0. Page number 0 is present inside the RAM. No, page number 0 is not present inside the RAM. So since page number 0 is not present inside the RAM, we are going to call it as a page fault, and this page number 0 we need to move from hard disk to RAM. Now we need to move page number 0 from hard disk to RAM. So now which page number needs to be replaced by page number 0? So among 2, 3, 1, page number 1 has a write first. So therefore page number 1 will be replaced by page number 0, right? So like this it goes on, right? Let me jump to page number 3. So now CPU is requesting for page number 3. So page number 3 is present inside the RAM. Yes, page number 3 is present inside the RAM. So we are not going to call this as a page fault. Instead, we are going to call it as a page hit. Right? Yeah. So since the contents of the RAM has not been changed, I have not written here, right? So next CPU is requesting for page number 2. Page number 2 is present inside the RAM. Yes, page number 2 is present inside the RAM. So we are going to call it as a page hit, not a page fault. So since the contents of the RAM has not been changed, I have not written here, right? Next CPU is requesting for page number 1. So page number 1 is present inside the RAM. No, page number 1 is not present inside the RAM. Since page number 1 is not present inside the RAM, we are going to call it as a page fault, and this page we need to move from hard disk to RAM, right? So in order to place page number 1 inside the RAM, we need to find which page number needs to be replaced. So first in first out algorithm says that the page number which has entered the RAM first, that needs to be replaced. So among 0, 2, 3, page number 2 has a write first. So therefore page number 2 is replaced by page number 1. So like this it goes on until the last page number, that is 1, right? So now we need to count how many page faults has been occurred. So in order to answer this, just we need to count how many times we have drawn the RAM. So how many times we have drawn the RAM? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So therefore the total number of page faults is 15, right? So why I have counted? Because whenever a new page is brought into the RAM, we have redrawn the RAM, right? So why we are bringing a new page into the RAM? Because the page is not present inside the RAM, right? So when the page is not present inside the RAM, we are going to call it as a page fault, right? I hope you understood this first in first out page replacement algorithm, right? Thank you. Thanks for watching. Thank you.